too.
Yeah, this, where's the here play? Now it should have.
Okay, thank you. Okay, well, that took a little longer than we thought. So anyway, I'm currently with the Arizona State University Research Enterprise, which is, I've gotten a lot of practice in saying this, it's a very small independent 501(c), but our sole beneficiary is the university. And we get our overhead funding from the university, but we can do certain things that can't be done in an academic or on-campus environment, especially on one that's a state school. And I also have an adjunct faculty appointment in the School of Computing and Augmented Intelligence. So it's very different being out in the desert and in the heat. But we have great colleagues. I don't know if any of you are here today, but great place to be. So let me start with, why did IAAI get started? So the first conference was in 1989, which, were any of you at IAAI that year in 1989? A few. I also want to ask other students in the audience today. Not very many, but a few. So I have a couple of comments for you. But 1989 was sort of the end of the first big AI boom that was really characterized by work in expert systems. And several people in the leadership of IAAI had recognized that papers about applications of AI, mostly again of expert systems, were not getting accepted in the main research conference. And they weren't getting accepted because they weren't traditional research papers. They were different. But the thought was that there was very significant and important work being done in applying AI to real problems, and that this work needed to be featured, it needed to have a venue, and it needed, for the good of the field, to be publicized. So people in the business community and the applications community and government, wherever it might be, would recognize the value of what's coming out of AI research. So I wasn't involved in these discussions. My understanding is that the prime mover behind it was Raj Reddy of Carnegie Mellon, and that he was in the leadership of IAAI, and so they started the Innovative Application Conference back then. And it's not only that papers weren't being accepted and needed a venue, but application developers not only don't have incentives to publish, they often have negative incentives, because bosses will say, well, if you let our secret sauce out, our competitors will be able to catch up. Now, there are sometimes more enlightened bosses, like one I had once, who said, if we're not 2 years ahead of any competitor, we're doing something wrong. So go ahead and publish, because that just means 2 years from now, what you've talked about now, somebody else might get to, and we'll have moved forward. So that's the type of boss one wants to have, and the type where I've tried to go. The purpose of IAAI was really to tell the stories. Ed Feigenbaum was another leader in the field, and he would talk about, he was on the program committee in the early days.
There's this core process of repeated
get the word out. So even if the paper wasn't really up to snuff, if it was missing some pieces, if it wasn't written in the right style, if there was an application that needed to be featured because it really showed the value of using AI in the real world, we would tend to accept it.
Have these issues, and you're going to
we felt that application developers needed recognition, not just researchers. This was very important, and I asked about students. Most of the students who are getting PhDs in AI now will not get academic jobs. I mean, in a steady state, every professor has one of his students, who can replace him or her over the course of a career, because that's just a simple steady state analysis. So most researchers, most students will end up working in industry and government and other areas that build applications. And it's important, I think, for everybody to understand what makes applications different, what makes them unique, what the challenges are into making things, why it's much harder sometimes, or it's certainly very different to deploy applications in the real world. Obviously, like any conference, you know, at any time there's a new conference, they list goals, and the goals is always to provide a forum to exchange experiences and lessons learned, you know, bring together people who work on similar problems so they can exchange ideas. And IAAI does that. I think this, you know, seating arrangement, maybe, and some of the things Jan spoke about, hopefully will lead to that today and the next couple of days. And I think this final bullet is crucial. Applications, in my view, and I think is shared with a number of people, really motivate good research. An awful lot of research questions that wouldn't necessarily come up in the lab, in a research lab or an academic environment, can be motivated by the needs of real applications. And I think there's a virtuous cycle between researchers and developers of applications, where applications are enabled by the latest research and the latest the list on things you cannot do in an application then goes back and motivates new research ideas. So all of these were reasons for starting IAAI back in 1989. So there's a lot of differences between applications and real things, but I just wanted to highlight this quotation. This was actually from his candidate statement when David Waltz was running for, nominated to be and was running for his election as president of IAAI. So this would have been in the mid-90s, I guess. And you can read the quotation. It is essential to develop an effective dialogue between basic and applied AI. And this really is put better than I can, saying why we really need a conference like IAAI and why it's co-located and why it's really part of the main conference. I'll explain in a little more detail how that worked over the years. But what are some of the challenges? What makes developing applications different? I'm not saying better, worse, harder, easier, just different from being able to, am I standing in the wrong spot here? Okay. So what makes it different from doing research, from the motivations that we might hear about, I guess, across the street now? So often when AI is deployed, it's a component of a large system. And this may be nowadays, it could be a system that acts in the physical world. It could be a system that acts in the cyber world. It could even be a complex information system in a large organization. So Patrick Winston used the phrase AI many years ago. He said, AI is like the raisins in the raisin bread. You know, it's a very small percentage by volume. It's a much higher percentage by weight. And most important, it wouldn't be raisin bread if it didn't have any raisins. Raisins add the taste and they add the flavor and they make it interesting and they make it much more useful than just, boring loaf of plain bread. So again, that's another president of IAAI who had really understood the difference between, how AI is deployed in the real world and doing research. Also, applications tend to have multiple different techniques. It may be that there's multiple techniques that are combined, some of which may be IAAI, some of which may not. It may be that there's been trade-offs between different techniques. If one's developing an application, the goal is to solve the problem, not to promote a particular piece of new research. So in that context, often applications developers will evaluate several different techniques and do a trade analysis and see what really fits the best. One of the things in my experience is that, often you find, maybe you have 3 or 4 things, criteria, or 5, whatever criteria you need to solve. But if you try and have a particular technique or tool that focuses on one of them and then moves off to some of the edges and does more of them, they end up overlapping and getting in each other's way. So the lesson I've learned over the years is you want to build maybe you can integrate 2 tools, rarely 3, and then not any more than that, the system gets too complicated and it doesn't really work because the tools each try to move on from a very basic core to do a lot of different things. Assumptions that are great to use when doing research. I mean, in research, we have to simplify assumptions and we have to isolate particular things so we can do experiments with, withholding all other things being equal so we can really draw sound conclusions. But in the real world, those assumptions don't always apply. They in fact, they very rarely do. So understanding the limitations of an algorithm, of when it applies, when it doesn't, an obvious one is with respect to data, where you have missing values or null values, and you have to figure out what to do about them. Another one is when the data is not IID distributed. So all of those assumptions are violated, and how do you get around that in the real world when you're building applications? Another one is about representation. The role of representation in AI, I think, is very important. Probably some of the large-scale machine learning systems don't focus on that as much now. I know Ron Brockman talked about this in his presidential address. So, representation is important. I was actually being interviewed for a job once, and somebody said to me, how do you the person who was making the decision said, how would you decide between this algorithm and that algorithm? I don't remember which ones were the popular ones at the time. And I said, if that's the question I'm dealing with, I've already lost. Because the most important thing in solving the problem is not picking an algorithm that gives you 1% more accuracy. The most important thing is getting the right representation space of the problem where it's easy to solve it and where you know what you're doing. I did get the job, and it resulted in one of my IAAI papers. Often there's a lot of data in any organization. You have to build, you can't build a standalone AI application. Back in the 80s, the expert system model was you connect to some database, you'd snarf it all up, and you'd stick it on your symbolics or other list machine, and it would do all sorts of fancy reasoning, and then maybe you could hit print and get a report. But in the real world, that doesn't work, because in the real world, there's lots of data coming in. It's being received by many different people at different times, and you have to put the pieces together. And Bob might get something on Tuesday that Sally gets on, related to something Sally gets on Thursday, that's related to something Ann gets on Saturday. And you have to, put all these pieces together. So you have to integrate carefully with the IT infrastructure. And what I just described as a made-up example, or notional example, really gets at the idea of sharing and persistence. And of course, as soon as you say sharing and persistence to any computer scientist, they don't think AI, you think databases. So integrating with database systems, and which is the main type of application you see in many industrial applications or in any large organization, has been crucial. You have to augment existing systems. If you come into users and say, gee, we're going to replace everything with this brand new system that's going to do your job better, people don't really like that. But if you give them a tool that allows them to do their job better, a few early adopters will play with it, and they'll realize, and then their colleagues will realize, hey, these people who are using this new tool are doing their job better, faster, and other people will want to adopt it. And I've had that experience in building real applications as well. You have to have a real user benefit. They have to not only be more productive, but what my kids, when they were very little, said was, Daddy, who's the in-charge person? Well, you have to make sure your sponsor, in the early days of AI, we call this a champion, the person who's responsible for, who makes the decision that, yeah, it's worth investing in these expensive, weird computer scientists who are building these applications, is getting his or her goals accomplished. I think I already spoke about this idea of multiple overlapping instances when data is coming in, and you have to look at many different things all at once. And more recently, we've talked about, in the community, we've talked about explanation. If we're making a decision, or if this computer system is saying, hey, we ought to do this, people have to know why before they'll accept it. And finally, at least in many applications, it's very important to have audit trails, to have archives. Why didn't you catch this thing? Why didn't you make a different decision 3 years ago? Well, 3 years ago, here's the data I had, and here's the version of the system I had. And here's why, maybe I would have caught it today with the current data, but I couldn't catch it 3 years ago because, we had an earlier version, or we didn't know something, or whatever. So in many environments, all of those things are important. So none of these things, these challenges, and there's probably ones I haven't listed, but then the font would have become way too small to see, are things that are very important in building real applications of AI. And these are the types of things we hope to hear about when we hear about when we get papers in IAAI. So let me go through briefly some significant events as IAAI evolved. The first two conferences in 1989 and 1990 were held in different venues at different times from the main international conference, from the research conference. The first one was at Stanford, the second was in Georgetown in DC. The proceedings came out, with the normal proceeding style, but they're also republished as a book, and I was trying to get, go and find an image to paste in here of the covers of the book. Unfortunately, I got defeated by the technology. I wasn't able to figure out how to do screenshots and paste them into the slides. So, but if you Google innovative applications or go to Amazon, you can find the books, or you can just look at them online on the IAAI website. In 1991, it was decided that the two conferences really shouldn't be that separate, so they were co-located. And the venue from then on is just the same venue as the main AI conference. However, there was still separate registration. You had to check a different box and say which one you were going to, and if your badge had the wrong color on it, you weren't allowed in the room. That I don't think was a good thing. So in 1993, we started taking the best or the most significant application papers and republishing them in a special issue. Usually, I think it's the winter issue, but not always, depending on the editorial schedule of the magazine. The proceedings were still kept separate. The registration was separate. In 95, we had a challenge because that was the first year that the conferences were co-located, but it was an IAAI year. And back then, we had the national conference was not held in IAAI when IAAI was in North America, and we happened to be in Montreal that year. KDD was also starting that year, was co-located immediately before the AI conference. So that was a bit of a challenge with IAAI leadership because the way the budgets work between IAAI and IAAI required some delicate negotiations to be able to have both conferences because the IAAI registration fees didn't cover the people coming into IAAI. So we were then, we were in the room in the same convention center, and there were many people standing outside the door who weren't allowed in because the student volunteers were doing their job properly and not letting people in if their badge wasn't coded well. And there were lots of empty seats and a very sparse audience in the room. And Howie Schroeb and I, who were going to chair the conference in the next 2 years, looked around and said, "This is nuts. Why are we keeping people out who want to be here and simultaneously not having enough people here?" So we did a rethink of the conference and decided that what we ought to do is have a complete logistical merge. Now, for many good reasons, we have separate program committees, and one of the things that comes up often is, well, why do we need an IAAI? Aren't applications covered in the main conference? And I hope I've convinced you so far, and with some of the examples I'll get to, that doesn't really work. So what we went for was a complete logistical merging, as you see today, except for a street we have to cross, but a separate program committee, and that's been the model that's worked ever since. It comes up for discussion every so often, but fortunately hasn't changed. Now, just because of timing, the call for papers already had gone out for 96. So in 96, we were able to do this joint registration, a common set of proceedings. They were identified separately, but the papers were all in the same book. We also added in a series of emerging technology invited talks. So I think we had one on KDD, which was hot at the time, from Park Smith, and a number of others, the details of which I don't have written down here. But that was the first year in 96 that we merged everything logistically. In 97, we had enough lead time. So at that point, we added this emerging track, partly in response to a fall off in the number of papers that were being submitted about deployed applications. So Howie and I came up with the idea of having this emerging track, and we called it, I think, emerging applications and tools and technology and issues, maybe not quite so many words, but emerging was the way we summarized it. We were very careful to distinguish, and we put an editorial in the magazine saying, what's different about this? The emerging, there were still, and there are today, sessions in the main conference labeled as application sessions, but they're different, and I'll talk about that in a little bit. In 2001, we were beginning the depth of an AI winter. There were only 12 papers in the conference, only 5 of which were deployed. There were serious questions about whether it would remain viable. And again, that was another IAAI year. 2002, Neil Jacobstein, who was longtime program committee member. Was the chair, I guess, gave a 20-year retrospective. And we added a number of things to the program, a panel on startups, an entrepreneurs panel, and some other invited talks. Robin Murphy gave a talk about her work in urban rescue, which is again being very close to, but after the 9/11. Ray Kurzweil did a joint invited talk with the main conference on human level strong AI. 2003, we were in Acapulco. This is when the Robert Engelmore Memorial Lecture Award started. There was a memorable talk by Luis von Ahn. This was the first time I heard about CAPTCHAs. Maybe some of you had heard about them sooner, but that seemed like a really good application. 2006, and again, I'm skipping years where there was not a significant change. 2006, there was a talk by, I believe, Sebastian Throne on winning the DARPA Grand Challenge. This was the first Grand Challenge. Neil also did a retrospective of what I guess he counted. There have been 362 innovative applications to that date. We had a talk in 2011 by David Ferrucci because a big application of AI that was well publicized was the work that used Watson to win on Jeopardy. 2013, we added yet another track on challenge problems. The idea being people with real applied problems could say, we need some help. We don't quite know how to solve this. Here's an area for research. So that was intended to help formalize the feedback. We've gotten some, but not a lot of papers in that track. In 2021, obviously it was a virtual conference because of COVID. We added some AI in practice panels again as an experiment. Some of these things survive from year to year and some of them don't. In 2023, we added some more tracks, an interdisciplinary track of AI integration. There was expansion of the challenge problems to best practices. We also added at some point ability to write papers. We were starting to get papers about large-scale tools that facilitated AI applications and were being made available, but weren't an application per se. In a sense, that was back to the future because in the very early days of the conference, an awful lot of applications were built on what some of us remember as expert system shells. Those companies tend not to be around too much anymore, but those were tools to enable applications. As we've all learned, that's not a great business model. So I just wanted to summarize give a list of winners of the Engelmore Award. It's sponsored by both IAAI and AI Magazine. Bob had been a longtime program committee member and force who was really helpful with IAAI in the early days. And he was also the former editor of AI Magazine. So that's how that award came about. And you can see from the list of award winners that a lot of these people have deployed real applications, many of which were reported in the conference. And I guess we have a talk coming up later from this year's winner. So as I mentioned on the slide with the timeline, we've had several other retrospectives and putting this talk together. I looked through these. Howie had an editorial in, I believe it was 96 in the magazine, where he reviewed the applications to date. He did a count. It's always hard to group the applications into different areas or different application domains because we change every year, based on the set of papers we have. So this was a count that Howie did, I think, in 96. I tried carrying this forward and I tried making a spreadsheet where I could look at, I was going to do counts and statistics of different domains and look at where they shifted, but the list of how to categorize them kept changing from year to year, so I gave up on that. He pointed out that there were really two broad categories of applications, which he characterized as the elephants and the rabbits. The elephants being the very large mission-critical applications that got a lot of publicity, and the rabbits being, and this was DuPont who really was identified as having followed the rabbit strategy of build a lot of small things to help people. And there were examples of both. There were many examples of both types of successes. He also divided things into three eras. He said that in 89 and 90, what we were really doing was just saying, hey, AI is real. It's not just something we do in the research lab or in universities. It's something that has real business value. Between 91 and 94, many of the papers were really expressing frustration with all the difficulties of integration. These standalone big applications were no longer, the big things we could talk about. People were trying to deploy AI more widely and have it embedded more closely inside of different organizations. And the papers all identified, maybe not 100%, but the predominant theme was what's really hard is integrating into an organization's IT infrastructure and making things work. And Howie looked forward in this editorial also and said, well, once technology evolves and we get tools for large-scale modeling and large-scale infrastructure of building applications, then hopefully we can return to domain understanding, to task analysis and matching the right technique to the right problem without having to deal with a lot of the lower level things. I don't know that that's happened completely. I think that there's, it's certainly been evolving and we've seen a lot of that in recent time, but I think Howie was ahead of his time, as he often is, with some of those ideas, even though he was correct about them, just off on the timing. Coming back to the raisins and the raisin bread analogy, integrating with conventional data processing is really hard, and putting it in the context of an organization with people also hard. So one example that Howie picked up on was case-based reasoning, which for many of you remember the early 90s, that was a hot technology. Most papers in the research conference were all about it. Few people in this room may remember case-based reasoning and still work on it. But Howie pointed out that the full paradigm of case-based reasoning when it was developed was retrieve similar cases, compare them to the current situation, and then modify or adapt to come up with the solution that would be applicable to the current situation. And he said, when we looked at most of the applications that claim to use case-based reasoning, what they really did was just the first part. They became information retrieval. And when we look at how case-based reasoning has evolved, it's really been seen and integrated not as separate AI tools anymore, but it really moved mostly into help desks and that type of user support. So one of the reasons that Howie speculated that case-based reasoning, the full research paradigm didn't get deployed, was simply because people are really good at adaptation. So the hard part was the retrieval, was finding similar situations, similar cases that applied. So again, the lesson there is use the AI for the things people aren't as good at, but don't try to do that for the things people are. I think the same thing happened with a lot of the early work in medical diagnosis systems, where we had some great successes with Nyson being the obvious example. But then as we move forward, people realized really accurate diagnosis is only a very small part of what doctors do. So it really didn't help that much. And that's one of the reasons that technology didn't go forward as well as it could have. Neil gave this great talk in 2006. I wasn't able to find the paper, unfortunately, at least not quickly. So I couldn't really talk about that. And then Reed Smith, when he has his Engelmore Award talk in, I believe it was 2016. I can go back to the last one and check. Yep. Republished the talk in the magazine, as the Engelmore Award winners are invited to do. And he gave a very good retrospective on what he called what we thought we knew then and what we actually know now, paraphrasing. You can see the link, or you can find it if you use easily if you find your favorite search engine. But his takeaway, and I'm paraphrasing, but not, it's probably 80% verbatim, he said, AI can only really benefit humanity if it's deployed. And in order to be deployed, it has to integrate not only into organizations, but into the human context of actual use and into the IT infrastructure. And he gave a number of examples of papers from IAAI that really supported that point. And it's a really good talk and a really good article in the magazine that would be worth reading. So one of the things I was interested in was different technologies that are reflected and deployed in emerging papers. So these are, there's probably some mistakes here. I did a keyword search by looking at the titles of all the IAAI papers that were online. And, I think I did the keyword search right, but there were some years when we didn't distinguish in the proceedings clearly between deployed and emerging papers. So this goes on both. I just picked a set of words that seemed important. If you have your favorite words not on here, I can certainly search it later or during the break if you're interested. It's interesting, and then I put down when the first and the last instance of seeing those words are. System's always there. Agent came into play a little more recently. Scale was evenly distributed over time as I reviewed this, but isn't mentioned that much, and I found that a bit odd. Expert systems were really in most of the titles at the beginning. Not so much recently. I think the last instance I found was in 2010. I looked at the word expert without systems, and again, it lasted longer. And part of that is because there are papers that talk about giving assistance to human expertise or capturing human expertise in a system, but not using what we call the expert system technology of simple rule-based reasoning. Knowledge has always appeared. I learned many years ago that if you replace ES with KBS for, change your expert system to a knowledge-based system, then all your acronyms don't work. So that's a good reason to still call things expert systems. Unless you want to speak Klingon, then maybe they work. I was looking for language because I wanted to see if we had some of the fields that we never really got in the conference in like natural language processing. When I searched on the word language, I got papers that use natural language as the application domain, but also things about, specifying a formal language or a domain-specific language, and I wasn't able to sort those out. So the language line here really includes both. Vision and speech had very minimal appearances in this conference. That's one of the things we've been frustrated about, we as program committee over the years. Probably because they have their own conferences that have applications tracks. Ontology first appeared in 2000. We keep getting using ontologies or automatically discovering ontologies. The different papers come up. I was completely unsuccessful searching for the word case because so many papers had the word were about case studies, and I'd find headings and things like that. So I couldn't distinguish without spending another day of sorting it manually between case-based reasoning papers and papers that just have the said we're doing a case study. So that was my fault for not doing a good job on search terms. And then I looked at learning. Learning wasn't in any of the early conferences. It was minimal. Now the more recent papers, it's hard to find one that doesn't have learning in the title. We also look at another way of breaking things out is not by the technology so much, but by the task that it's accomplishing. So we talk about AI doing planning and scheduling. You can see those are really evenly distributed over time. There's a lot of planning and scheduling applications. At one point in the program committee meeting one year, we were joked about, yep, here's another scheduling and planning application from NASA. We would get one every year. They were all good, but that became a concurring theme. And then recommend, I put an asterisk there just for an autocomplete because I looked at recommend, recommendation, recommender, different forms of the word. And that technology, didn't really start until 1992, a few years after the conference, but it's continuing today. We could have done this also by application domain, but it was so hard to figure out the search terms that I didn't do that analysis. So I thought it would be interesting to look again at the history of the conference in terms of the number of papers. So green are deployed application papers. Blue are papers that when there's blue and green in the same year, it shows deployed applications in green and the blue are all the other tracks. When there's only blue, it does not mean that there were no deployed applications. There were deployed applications every single year. It's just that the proceedings versions that are online unfortunately did not distinguish them. They were divided up by application domain or technology. So you might have, a session, say, with 4 case-based reasoning papers, 1 of which was deployed and 3 of which were emerging. And the online proceedings don't make that distinction. So when there's only a blue line, it just means that I couldn't distinguish between them. But you can see we had, some dips. There was a dip this year, here in the number of papers. But roughly, it's in a few years had spikes for reasons like, I think it was a pent-up demand, and it was the end of the first AI boom over here in the beginning. And then maybe in the last, 6 or 8 years, with AI becoming more popular, we've seen a lot more papers coming in. But I'd say with a much lower acceptance rate, whether that means we get, the quality is the same of the submissions. I mean, the quality of the accepted papers is the same, but maybe we're getting just a lot more, or maybe there are a lot more. Sort that out. So let me take a water here, and then let me reflect on what do we look at? What are some of the things that make a good application paper? Why can't I open the water? There we go. So I'm speaking mostly about the deploy track. We've always wondered what makes an application innovative. And we've had 4 categories on the review form. Novel AI techniques. It can be innovative because the developers had to come up with a new algorithm that could stand, up to scrutiny in the research conference. That's clearly innovative. That's the easiest one to tell. Now, that said, a paper that's all about the algorithm and is not about the application, it's not about what made it hard, what was the experience in deploying something in the real world, that paper belongs in the main research conference, and they go there. Occasionally we get those papers here. In some years, the program committees can coordinate and they send things over to the other conference, but usually it just gets rejected and says, try the other conference next year. A second type of innovation is when there's a novel integration of techniques, when several different algorithms or things that have been done independently are put together into a larger system that's necessary in order to solve the real problem. And those other techniques don't necessarily have to be AI. We've had things like AI combined with signal processing, or AI combined with operations research techniques, and try not to be too picky on the definitions and making fine lines there. Those get into the how many angels can dance and the head of the pin type distinctions. But those are real things. That's novel if we see a paper that says we're integrating AI with something else that hasn't been done before. And finally, sometimes there's nothing new at all from a research perspective. Sometimes it's AI being applied to an application domain that one would never have thought of. And I'll show you an example of that upcoming. I'll preview one that, 1 year, only 6 more minutes. Gosh, I better speed up significantly. Thank you. Innovative, 1 year we had a paper about just using simple expert systems. I think it was the New York State income tax. And there was nothing technically novel, but the fact that you could get a lot of mileage out of a well-known technique was interesting. And there's another example of that coming up. So again, papers have to be deployed. So what did it mean? What does it really mean to be deployed? Well, it has to be in use and relied upon for real decisions with respect to the organization's mission. And we arbitrarily, or some good reasons, said for at least 3 months. So you can't say I turned it on last week, then the answer is resubmit next year. It really has to be on for at least 3 months. There are exceptions. So there was a NASA paper 1 year about a principal investigator in a box that was flying on a mission to, I believe, Mars, and it was designing experiments to be carried out automatically by the robots. The duration of the mission wasn't 3 months, but it was in real use. So we counted that. There was one from American Airlines when there had been a competitor had announced some sort of promotion on their frequent flyer program. If you did so many round trips or something, and American decided to go do them one better, and they had a paper. So this was a one-time run. It ran over the weekend, and it had to do with how do we decide if something counts as a round trip? And apparently that was very complicated given the state of airline systems then. Because it's not just, there's the obvious round trips where you fly from X to Y and then back from Y to X on a single ticket. But what about open jaws? What about, you go back to a different place? That's co-terminal. There are a lot of complications. Another heuristic we use is that the user should really be distinct from the developers. You can't say, I built the system and I tested it myself. That doesn't count. It's not deployed. It's deployed when there are users who are in a separate organization, ideally. Now, sometimes they're the same. When the computer scientists collaborate with the doctors in the medical school in the same university. Well, that counts because the doctors are the users and the computer scientists are the developers. We don't insist on being a separate university there. We had one year where there was a paper where they said, well, there's 12 factories and we've been deployed in 3 of them for however long it's been. And we talked about that for a while and said, well, if there were only 3 of these factories in the world, we'd say it's good enough. We shouldn't penalize them then because there's another 9 they haven't gotten to yet. They've met the criteria. And there have to be clear measures of effectiveness that measure the business value, how it improves the outcomes, not just the usual technical metrics of accuracy and so on. So occasionally in program committees, we have to remind ourselves it stands for innovative applications, not imagined applications. Papers that say, well, we think there could be an improvement in taxi service in the city, so we'll imagine a 6x6 grid and model it that way. There has to be an end user pull. There has to be some organization, and this is really key, that's motivated to have an application that solves a problem and provides value. If there's no quantitative metrics, it doesn't count. It has to be relied on. And we've also seen, papers where they say, well, I use real data and I developed a model and look, my algorithm works and I get better outcomes. No one's using it. No one cares. Sometimes graduate school class projects fall into that category. And I mean that as more derisively than it even sounds. They're important things to do, but it's not there. So some other things, because coming back to tell the story, when we have a deployed paper that isn't quite up to snuff because the people writing it are under time pressure, they're disincentivized, they're not experienced writing research paper. We end up sometimes accepting the application and we appoint a program committee member to shepherd it to help revise the paper to make it better because we really want the application story to be told. So I'm just going to very quickly, until I run out of time, go through some, I'm sorry? Thank you. Okay, well, maybe not so quickly. So I'll get some, these are some applications that just stuck in my head. These are not the best, necessarily the best ones. They're not necessarily comprehensive. They're more of a random set that I just happen to, I remember for one reason or another. I'm sure, I was told once that Harvard looked at their freshman class. They then took that freshman class out of the applicant pool, just as an experiment, and then took the remainder of the applicant pool and said, okay, if that's all we had, who would we admit? And they then discovered that the second group who they would have admitted, who didn't get admitted, were indistinguishable statistically from the group that actually got admitted. So even if you don't get admitted, that there's a 50%, at least a 50% probability that it was by chance. And I feel that way about these applications I picked. I could have easily ignored all these and come up with an equally good list and maybe done that 2 or 3 times. So very early on, we had a memorable paper from NASA. This was in the first year, John Moratori and his colleagues. They used it to help in mission control for the space shuttle. They were worried that there's, you've all seen those pictures of mission control where there's lots and lots of consoles and data is coming in and you have to integrate it and know how do you make a decision right away? Do you hit the abort button? So they built into the system that was reported in the first conference that helped do automated fault detection. And it actually became accepted in use when it discovered faults in the engines on an earlier version of the shuttle that people didn't discover. Another one from the first year was this American Express Authorizer's Assistant. This was used to process all transactions on American Express cards. It never said no. It only said, yes, this transaction's not fraudulent and ought to be accepted. And then if there was no, it would get bumped to a person to make a decision. But they had, they said 890 rules, thousands of transactions a day. It's probably a lot more now. And then American Express continued using a lot of AI. They had one that they reported in '92 on credit granting. The system was noteworthy also because it was available 24/7. In 1990, we had one from a small company called Resumex. We all see nowadays that resumes are read by computers, but this was really the first reported use of this technology. It came in IAAI, and you can see the long list of companies, some of which no longer exist, like Digital Equipment, that had employed this technology. And it wasn't just to read a resume, but It was to match it to the job description and then prepare a letter that a hiring manager could say acknowledging it. There was one from a large vehicle manufacturer, the Eaton Corporation. They were in Wisconsin, I believe. And this was noteworthy because it's the first one I found that actually said it combines neural and knowledge-based techniques. And we've had a paucity of neural applications. It's become neural symbolic, has become more popular in recent years. But they were using sensors to measure brakes. They built large trucks. And that's where the neural technology was looking at the sensor data, and they were comparing it, evaluating the graphs that they got out of that using knowledge-based techniques. We've had lots of scheduling applications over the years, and as I said, many from NASA, but we've also had them in academic domains. This was one that was scheduling classes and assigning, and faculty and students, as I forget where. We've had other ones in academic environments as well. There was one year where one of the universities, I remember which, but I don't think I'll say now, was using it for graduate admissions to help screen the applicants, at least for a pre-screening, or more of a triage. And I mentioned this American Airlines application a few minutes ago. They had another one on what they called hub slashing, and they actually had an extra S in, maybe it was in the word slashing. If you Google this phrase, it might not show up. I think the spell corrector has taken away what I actually tried to type here. But that was looking at what happens when a hub is shut down because of bad weather, for example, and how do they reconfigure everything. In '93, we had a large-scale system from AT&T. This used C Classic based on KL1 and description logics really for the first time. So, Ron, you had an influence there. It extended, a lot of the work in this paper talked about things from the more famous configuring system that was used by DEC that was called R1 and then called XCon in a later iteration when it was more deployed. And there's a good section in this paper that says, here's all the things that didn't work and here's how we tried to fix them by what we did in this AT&T system. So I thought that was notable. And then this PI in a box from NASA was actually used on a space shuttle mission in 1993 to plan experiments. This paper was from General Electric. What was interesting here, and for any of you who have been working on it, had an application that's long lived in a particular environment, this is one that was a 10-year retrospective. General Electric, or one of its subsidiaries, General Electric Plastics, would manufacture plastics of particular colors. And this was a real challenge. What's the right mix of chemicals to get the color to match exactly what some customer might need? And they used this system for over 10 years. And we had a paper from Bill Cheatham, who had been on the program committee for a long time, about this General Electric system. And, one of the things that we have done in the program committee is we've accepted papers where, maybe you have a paper that says, here's my application, we just deployed it 6 months ago and it's doing great. And then 3 years later, or 5 years, or whenever, we get another paper saying, here's how it's lived, here's the long-term life cycle. And that's another thing that is of interest for IAAI. Now, in the case of General Electric, they had some follow-up applications. They extended it to a service for customers. So a customer could say, here's the color I want, and could build. Now, this was something they didn't make money off of, except indirectly by getting a service for the customers, but they didn't charge for it. So they couldn't really evaluate it in terms of cost savings. And General Electric, research labs supported many aspects of their business. They built a system for insurance underwriting for both long-term care and life insurance. There was one for appliance customer support when you call them and your refrigerator or washing machine didn't work. And then they had one on mortgage insurance, right, underwriting. And it's only because all the ones above it were based on case-based reasoning that I said the last one wasn't. They've had a variety of different things. I don't remember if they had others. This was an interesting one. This is the cucumber farmers in Egypt. This is one where, nobody would have expected it, which is why we remember it. They had a grant from the United Nations, and they built us an expert system. It's actually the 3 different domains, what they call disorder remediation, plant caring, and fertigation, which is a word that I'm not quite sure what it means or if it's a typo. Might be a cucumber farmer. But they had a nice paper about this. It was not, this again is in the category of applying a well-known simple technique to a different domain. what was noteworthy here is they did the development in using an expert system shell. I forget which one. But then when they deployed it, they rewrote everything in Prolog because they didn't want to pay the license fees to the expert system shell company. And Prolog was available much cheaper. They started out with an English interface, but the farmers, and these were not very literate cucumber farmers in Egypt, spoke mostly Arabic, so they added an Arabic user interface, and it was interesting that this was one of the first bilingual applications we saw. And you can see the benefits that they got. I have no idea what happened with this one, but this was just a really unusual paper. There's another paper about poisonous tree frogs in Australia one year. I don't have that on my list, but we got all sorts of interesting things. That was another one that's accepted. I just haven't found it recently. This paper was from Thomas Sandholm in 2006, and we actually gave it, I think, double the time in its pages because this was probably the most exciting or the biggest payoff application where he developed some new algorithms for optimizing combinatorial auctions and used this for supply chain management when you have many, thousands of purchasers and thousands of items and different suppliers. And we're trying to make that process more efficient. So this was one of the most noteworthy applications we had over the years. And obviously, Thomas has gone on to win many other awards for his work in this area in electronic commerce, as well as his work on poker and other games. So this was a really major one, so I couldn't not include it, but it was very memorable. More recently, and in the last couple of years, we've one of the things that struck me when I was looking at the recent applications, and I didn't include this year because again, I didn't want to steal anyone's thunder. But if I look back in 2004, there were some papers. And what's interesting here is the applications, the problems, the business problems that are trying to be solved are very similar. Again, we're automating claims processing insurance, or doing optimization for loan underwriting, or scheduling at airports. And again, we've seen these over the years. We've had a lot of port scheduling. There's a number of papers from Singapore, for example, over the years. So applications haven't changed that much. But we have new techniques and the new a lot more data. We have some new areas that have become of concern. We didn't worry about privacy. We didn't know about federated learning way back then. There were no papers on knowledge graphs. So the techniques, the AI has evolved, but some of the business problems have stayed the same. And I wanted to highlight this other paper from 2003. I think this is the paper that had the most authors. So one of the things, I actually had a paper rejected once, it was not in IAAI, in another conference, where the reviewers said, you have too many authors, and this should be 7 or 9 different papers because you have lots of different ideas in them. And being in industry at the time, I was happy to get the time to write one paper. So large in research, we tend to look for smaller problems that can be very well defined, well bounded. This paper in 2023 with 47 authors from almost that many different institutions. It was a project funded by the European Innovative Medicine Initiative. They had a project called Melody, and there's not typos there. It's actually with 2 L's and 2 D's. It stands for something, I think, but I don't remember what. There were 10 pharmaceutical companies. There were a number of academic research labs all over. I think some were in the US, mostly in Europe. There were a lot of large companies. There were startups. There were all sorts of different people working on this. They had a large infrastructure with Amazon Web Services running Kubernetes and clusters. But the key is the companies are competitors. They didn't share their data, but they were willing to collaborate in the interest of discovering new drugs that would be helpful for each of them. So this was a really interesting paper. And they actually had a companion paper that focused on the scientific discoveries. I believe it was, I don't think it was in the AI literature. I think it was in the medical or drug discovery literature. But this is something that probably couldn't have been done many years ago. And I think it's one of our most noteworthy papers also. So honestly, I'm going to skip that one. I talked about the final bullet here. I guess I won't skip it. I want to talk about the third bullet that, there are many industries where they had a lot of investment capital, like airlines. So we see a lot of airlines papers in the early years. Then airlines became a really low margin and competitive business, and we don't see any more airline papers. So we see that the the areas in which AI gets applied tend to be in areas where there's leading companies with lots of money to invest and they want to stay ahead. It tends not to get applied, or at least we don't hear about them in areas where where there's low margins, where the company is trying to squeeze out every last bit of profitability in the short term. So I talked about we have to have real metrics that focus on the benefits to the users, to the organization. These can be higher productivity, better decisions, cost savings. They could be monetary, they could be in time, they could enable new functions, new customers. But again, these are measures of effectiveness. They're not the traditional measures of performance that we see for research papers. Research papers will typically have a table and we'll say, here's 6 algorithms and 6 metrics, and look, my new algorithm works best on 5 of them, whatever. And people are told that's how you do it. That's how you get your paper accepted in the research conference. But of course that happens because of course your algorithm, which is tuned to your problem, is going to work better than all the others. And you pick the metrics. But here we need objective end user metrics. So I wanted to talk a little about what makes a really good deployed paper. So, one type of deployed paper we could have, we haven't had many of these, we've had a couple, I think, where there's a paper in the emerging track where it's intended to lead to something deployed, and then maybe a year or two later, it actually gets deployed. That's okay. It's okay if we have, in fact, that would be a really good situation to see, and we're hoping to see more of that. I already talked about the General Electric example about the history of long-term deployed applications. How is the knowledge maintained? I mean, one of the reasons that expert systems we deem to fail is because it's really expensive to keep knowledge bases deployed, even when there's a positive return on investment. What happens how do they evolve, not just because the knowledge or the environment changes, but maybe the underlying IT systems change or the environment, the business requirements change. So looking at these long-term case studies is something that would be very interesting for IAAI. Really good papers, at least in the early days, would have co-authors from both the user organization and the researchers. Here's my research, here's how I built the system, and here's the real user benefit. Those tended to be some of the stronger papers. Papers that say, here's the research on which that enabled my application. Here's trade-offs. Why did I pick this technique and not another one? And what is on the too hard list? What additional research is needed? Those papers formulate the dialogue that's really helpful. Papers that don't just say, look, no hands, look what I built, but that can teach us lessons that people in the audience could apply on their own work in different applications are highly sought after. I've already said there's papers with a large number of authors are entirely appropriate. They don't have to be. You could have 2 authors, or you could have 20 or whatever. That's okay. And this year we have these or more recently, these newer tracks, not just on interdisciplinary AI. Maybe some of the papers from the bridge programs would help there, but also we've added the tracks on the incidents and best practices because AI tends to be more widely deployed in many different areas. So I just wanted to comment quickly on the emerging track. They have to be about projects that are on a path to deployment where there's where there's a reason for developing it. It's not just we did research and we had some real data and we did something in application domain. That means you have to have clear measures of effectiveness. And we don't do shepherding there because if it's not ready, it's just not ready. And the program committee is not really set up to do that extensive shepherding. So this is just my last slide. The one that says, let's have a discussion. Thank you. We don't really have participation from the large AI companies. The things we all read about in the popular press now, they've disappeared. That's a frustration because a lot of the things get deployed and extremely widely, and we don't get that. My speculation is that because their techniques and models are proprietary, they don't want to publish because there's a higher ratio, there's so much money involved, and there's minimal incentives to publish externally or openly. Or maybe it's just that they're worried about publicity and the environments and different constraints. I don't know maybe there's some reasons I haven't thought of. I'm sure I haven't thought of everything. It's also interesting that, and especially with machine learning, things get to the cycle of develop and then deploy and maybe have some feedback and do a new version has been compressed almost continuously. So that may affect what we can hear about and how things are different. There are also many research conferences, including IAAI, that have what they call application sessions. But there's also some that actually have industry tracks and so on at specialized research conferences, and maybe we're losing papers to the specialized conferences, just like research papers might not go to IAAI, they might go to machine learning or ACL or whatever. So these are just some thoughts, hopefully for some discussion. And I want to thank everybody, thank all of you, thank all the PC chairs and the PC members who've helped us develop a lot of these ideas and many of the discussions we've had over the years. So thank you very much.
Thank you so much. Very inspiring. We have room for some questions. I think coffee is also here if you already moved coffee, so you don't have to change to the other building again. If you want, you can just stay here the whole day. But there was one question. Yeah.
Right.
Yeah, great talk.
Thank you.
One of the things I didn't notice anywhere in here was any mention of deployed projects for national security. I think half of them are not, we can't talk about.
Probably just because I didn't happen to pick them. Obviously, I've worked in that area a lot, so there are, and I know of many that can't talk about it all. I think there are a lot of them. Yeah,
It's the very first session.
Yeah. No, it's not that they don't exist. They do exist. There's been some that have been reported in this conference. But there's a lot more. Just tip of the iceberg because for obvious reasons they're not talked about publicly. Yes.
Thank you for the talk. It's mostly retrospective, which was very informative for people that you forward project a little bit and where I see things going, how we're working together. Quite a lot of, yeah.
Well, I think the short answer is no, I can't. As they say, prediction is difficult, especially about the future. And, I first heard that ascribed to Niels Bohr, but maybe otherwise. It's actually very easy to predict about the future. What's very hard is getting it right. So, who watches pundits, cable knows. So, I think, I think the conference is healthy now. Whether we end up in an AI winter because whether one of the things I've been thinking about is in the context of what's happened over the last 30 or 40 years and previous AI booms, what does that mean in terms of the current boom now? One of the things I've seen in the past is that technology, like the example I gave with case-based reasoning ending up in help desks and rule-based processing moved from expert systems into business rules and business and databases. So, one possible path forward is that a lot of what we're seeing with large models now could end up, sort of fading into the woodwork and becoming another tool in our toolkit. This is the most optimistic scenario. Maybe it will end up, people will all recognize, okay, these things have limitations. They're good for some things, but they really work in the context of integrated systems with many different techniques. Again, that's where I hope things will go. But I can also see two extremes. We could end up with an arms race where systems get deployed and some disaster happens and lots of people die, and then we get overregulation leading to another AI winter. That would be really bad. Another possible future is what several years ago we called the scale is all you need crowd. Maybe miracles will happen and all the more traditional techniques won't be needed. But those last two I described, low tail probabilities to, and the one in the middle of hopefully the current trends will resemble the past trends where we just get more techniques and we all understand them better and learn how to apply things when they work and when they don't, when we should use them. Those are my current thoughts on where we might be going. How that relates to what we'll see in IAAI, I haven't thought about much. Yeah.
In healthcare.
Mhm.
So the evaluation of that kind of technology. Would that considered as some kind of a worthy experience to share?
Yes, I mean, how to do evaluations, I think, is definitely something we care about, and very much so in IAAI. Yes, I hope we see papers on that. I don't think we have yet. Yeah.
Maybe one question, I was wondering why we don't see so much engineering applications. If you look at the companies, there's so much happening, but if you look at research, it's seldomly is not steady.
So there have been a number, I just didn't happen to pick them because I had enough slides already and to use up the time. There's been a lot on helping engineers with design, especially very complex design. I think another reason is because we've seen, papers like that go into engineering conferences rather than, where engineers are more likely to publish with their colleagues than we've seen in the AI conference. So I think there's one, I just didn't happen to select them, but we have seen them, and they have other venues to go to.
Then let's thank Chad again.
The presenters are here for the next session. Could you see them, please? Thank you. Probably farming on.
Where's the USB-C? This side or? No, I can't see it.
See right here. That's going to power the phone.
Yeah. So where did he unplug it from then?
Maybe his own computer?
So we'll have to stop the share.
Yeah,
because-
I did.
Oh,
I did. You can just put it on top.
Really?
Yeah, sure.
maybe just.
No, it's
Are
fine.
you sure?
What's that?
Okay.
I'll be okay.
Okay.
You're fine.
So you
Do you,
can hear?
do you need the clicker thing, right? This thing.
Okay. Yeah, sure.
Or no, maybe you have your own.
I don't know my own.
Okay,
Maybe-
yeah, sure, that's fine. So do you know where to find
This one.
you know,
Yeah.
the other side? Yeah. Do you know where to find the Zoom link?
No, I don't. Sir.
Are you registered on the underlying site?
I am, but
So-
I think I have forgotten my password. Sorry.
So you need to log into the underlying site.
Yes.
I just sent the link on the app. So. Which is fine. So if you go to the last link. And it's worth it for, let's say, site security. That's right. Yeah. Okay. What happens when you say draft, does it give you the complete? Even 2 years ago. Yeah, I think now you can.
You join it now on your phone, you just need to.
If you look at participants or something, there must be a login like
Sorry.
that screen. I think there must be a.
Yeah.
Here, is there a?
Participants, yeah.
Yeah, participants list. Somewhere.
I'm trying to find this.
Participants. So you click on the screen, I think it comes up. Yeah.
So I also have an idea if I can just move your laptop for a moment.
What's your email? I have the link. I can just email it.
That's exactly what I was about to do.
I see. So with software products come software vulnerabilities. So a software vulnerability basically is a flaw in code that leads to problems with like compromise in security, even data. And these vulnerabilities are generally standardized by this corporation called MITRE Corporation, and they publish them in common vulnerabilities and exposures database. And what we have seen is that in the recent years, the number of CVs published every year has gone up exponentially with 38% increase in published CVs in 2024 itself. In healthcare industry, such software vulnerabilities do lead to patient safety risks, patient privacy, and sometimes it often leads to misdiagnosis as well. Among all the industries, healthcare industry is the one which have been having the most financial losses since 2011. And so that's why FDA requires all medical device manufacturers to monitor the third-party software components for new vulnerabilities throughout the device lifecycle and publish vulnerability evaluations, which are just assessments of how the vulnerability affects the product for each product and vulnerability. Now, what does vulnerability evaluation mean for Siemens Healthineers? So as I said that we have assets. The assets data database consists of all our products. And then there are notifications that we get from the third-party vendors, which consists of one or more CVEs. And these CVEs or these notifications get analyzed by our cybersecurity experts to form vulnerability evaluation. And so in general, what they do is they look at the vulnerability, they look at our product and try to have a detailed explanation of how our product is affected, what are the mitigations, whether some of the mitigations already exist, etc. And that is contained in internal comment. Now, we also write a succinct security advisory for our customers. And so that is our customer comment. VEX category generally says whether the product is affected or not. In case the product is not affected, then VEX justification kind of says why the product is not affected. And finally, we have environmental vector, which is actually a component of a larger vulnerability scoring system called CVSS. And most of you, I guess, know what CVSS is, but so it has three types of scores. One is base score, which measures how easily the vulnerability is exploited and its impact. A temporal score, and which says what is is the remediation available, and it changes over time as well. Whenever it changes, we get notifications from our vendors. And then we have environmental score, which our organization computes for our product, because we already have some security measures in place. So depending on that, we can say how much our product is affected or not. And so this is a sample input and output. Organization, software, and product, these come from the assets database, our database. The notification and temporal vectors, they come from the third-party vendors. And components present in software is basically an intersection between the components that are affected by the notification and our own components. And in the output, you see for this product, the VEX category is not affected. Since it is not affected, we have a justification why it's not affected, that the vulnerable code cannot be controlled by adversary. And then the environmental vector is generally not applicable when VEX category is not affected. And then we have a very long internal comment, which kind of says why it is not affected. And the customer comment, as I said, it's very succinct, and it just says the vulnerability cannot be exploited. But is this information generally sufficient to perform a vulnerability evaluation? Our cybersecurity researchers or our cybersecurity experts say no. They consult many other resources to do that. And like, obviously there are many reasons because they want to see what else is going on. But one of the reasons that they say is that CVEs can have very different descriptions, but can refer to the same weakness. Like as an example I have shown here, the weakness is just improper control over how system paths are resolved. But if you see the wording of those CVEs, even though they are standardized, they can like vary widely. So our cybersecurity experts in SHS, they generally consult other databases as well. Two of the most consulted databases are Common Weakness and Enumeration, or CWE, which sort of sorts the CVEs in based on their underlying weakness, and then those weaknesses can be exploited by some attack patterns which are enumerated in the CAPIC database, which also talks about prerequisites or what is the typical severity, etc. And and there are very nice researchers out there who have made a knowledge graph out of all these disparate databases as well, which we are using. We are using a very small snippet of it where we just use CAPEX, prerequisite mitigation, and typical severity. And so combining all of that, this is our actual input, which is input from assets, input from notifications, and input from the knowledge graph. And yeah, so doing all that does take a lot of time. And I have written here slow evaluation, but it is not actually that slow if you think of how much you have to go through to check whether vulnerability actually affects the product or not. So over a period of 1 month in early 2024, we did a study to see how much time they take. And we have seen that the average time taken is generally 194 seconds. Obviously, the median time is low because most of the vulnerabilities, it just takes 1 minute for them, which is very low. But the number of vulnerabilities that come to us every year, or sorry, rather every week, and the rate is so high that we need to do faster, we need to work faster, we need to get to the critical issues faster. So there is some need for automation. And then Siemens Healthineers has various subdivisions, and all subdivisions have their own cybersecurity experts. So we have seen that there are quality issues, there are inconsistency issues throughout all these subdivisions. And finally, as I said, our device lifespan is 20 to 25 years. Cybersecurity experts leave, they retire, and the knowledge goes with them. So we need to preserve that knowledge somehow. So that's why we thought, can an LLM or generative AI be used to automate evaluation of third-party component vulnerabilities? So we used the historical evaluation of vulnerabilities that had been done by product experts, and we trained an AI system to see if we can efficiently and accurately generate environmental metric, the VEX category, justification, internal, and customer messages. So how did we do that? So after training methodology, I know it's a very complicated diagram, but the gist is that we used domain adaptive pre-training followed by supervised fine-tuning of MPT 7 billion model. It is a model from Mosaic ML. I'll come to why we use this model later. And for domain adaptive pre-training, we have used 350K vulnerability description documents. Majority are them from the CVE database, and some are from our own database. And for supervised fine-tuning, we have combined the assets dataset, the notifications dataset, and all our evaluations, and found 719K unique instructions. Finally, when the model is trained, it is deployed, and that deployed model gives outputs to the cybersecurity experts in all the divisions, and they finally check whether it's correct or not, and whatever their suggestions are go back to the evaluations dataset again for retraining. I'll tell you later how often we retrain. So yeah, these are some of the training details. The SFT instruction format basically follows the alpaca format. For the instructions, so for one evaluation, we found 4 instructions. One is with VEX category and VEX justification. Another is internal comment. One is for customer comment. And for the environmental vector, it is in the form of, very inscrutable, string, so that we expand into proper description, and then we have trained with it. So as I promised, I would say why we use this. So initially we chose this model because some of our instructions are really long, like it can go up to say 13K tokens. And so we thought that at that time, MPT7 billion had alibi encoding, which did provide much better results with longer context. And after choosing that, later we did a study with other open source LLMs. And we also did a RAG study where we took the product, we took similar notifications, and we saw if this problem can be solved by simple RAG, but we didn't have good results. With Mistral and Llama 2.7 billion, which were the standards at the time we did the experiments, still it didn't give as good results as MPT7 billion. So for those reasons, we chose MPT. Okay, so now we're coming to deployment. So it is deployed in our cybersecurity management service. So they have already been using this application, this web application, to note all the internal comment, customer comment, and everything. And so we just what we did is we put our results in shared blob storage. So every day, at certain point from the CSMS storage, we get new notifications and the new products. And we have a cron job running in our server, which does a batched inference using the trained CVE LLM model. And we do then a bit of rule-based preprocessing, which uses business knowledge. The batched inference uses something like an adaptive batching, where we batch smaller instructions, we separate smaller instructions and larger instructions sort of, and we do a zero-shot inference. And then the inference is done on our server using VLLM, which is a very nice open source library for LLM inferencing. And these are then checked by our cybersecurity experts. I'll show you actually an example of how it is done. So this is the cybersecurity management service. And then they have put a very nice, so we're just a very small part of it. So that small button is for us. So they just click that button, it just fills it with all our, with what AI has generated. And then they change our, if they want to, or keep it the same, and then they submit it and it goes back to the evaluation data set. We do checks whether our performance is falling or not, and we do retrain when we see that the performance has fallen quite a bit. So what are the results? Now, the results I will talk about are on two data sets. One is the test data set that is from the historical evaluation data. And the other one is a post-deployment data set that we collected from May to July in 2024. It has 10K evaluations. And the metrics for evaluation are simple. For internal and customer comment, which are just text, we use Rugel, and for the others, we use Micro F1. So for test data set and post, so if you see the performance dips a little bit for post-deployment data set on an average, but for environmental vector, for example, it has maintained it has been very doing very well. Vex justification as well, it does perform very well for internal and customer comments that have been our point of problem points for now. And so we did ontology integration, and that is one of our observations is that ontology integration did not really boost our performance in the test data set, but we saw that without it, our performance, so we did one more study before this where we did not put any ontology in, and we saw that our performance was degrading. So that's why we put the ontology in, and we saw that it is not degrading as fast. So the number of times we have to retrain is smaller. Like right now we do like every 5 months, but that also we are improving and trying to not retrain as often. We did some ablation studies as well, just for publishing here. So, but domain adaptation we did quickly because we initially started with just SFT, and we saw that domain adaptation we got better results. For like during inference, we did for temperature and nucleus sampling, we saw no changes. And then for beam size, there is a lot more diversity with higher beam size. And our the generation that we want is a little bit constrained generation. So with beam size, it doesn't work as well. And obviously VLLM, it makes our inference faster. And then finally, what actually made them deploy this application is that the AI supported evaluation is 50 times faster. So it takes right now just 4 seconds for them with AI supported evaluation on average. So that's why it is deployed currently. And yeah, so on to discussions. Obviously, you have this question and everyone knows that we'll have hallucination. Mostly the hallucinations are with the named entities, like we get the version wrong, we get the name of the component wrong sometimes. I'll show you some more examples in a bit. And then we have some spurious text generation problems that were going on. And like after the whole text is generated, they will say vulnerability, 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 and it just doesn't make sense. It is more so with Llama and Mistral, less with MPT, but we saw it all the same. There is some performance degradation due to long instructions, almost 10% decrease over all the generations. And there is another problem that we saw is that not all subdivisions do their vulnerability evaluations regularly. So some will have very little data, and due to that, the generations for them tend to get biased to, like, they get their structure is very much like some other division. So that is one of our problems that we faced. And here are some examples. I don't think I have too much time, but as you see, there is some wrong generations. There's sometimes omission of important information, addition of spurious information, and wrong key information. Finally, on observations, we saw that domain adaptation was the biggest clincher for us. It prevented a lot of hallucination and improved our generation quality. Underrepresented classes in the classification still has problems, and we are working on solving it. And obviously, ontology enrichment also helped us a lot in reducing the number of retraining. So yeah, it is right now deployed in Siemens Healthineers. It has been deployed for almost 7 months. And it is human in the loop AI-assisted vulnerability evaluation, and it does improve speed quite a bit. And we are also working on various other methods, like improving it by integrating more pen-tested data, more information about our products, taking in more information about, say, vulnerabilities from different other sources. And obviously, there are many new techniques and reasoning models that we're trying to use. So hopefully, I will see you again in a conference publishing this. So, yep, thank you. Questions? Yeah. Okay.
About time of acceleration is very impressive. But the force negative. So people when they build out and identify something, they misidentified something. We don't know what to talk about. Was that actually the husband?
Right. So generally, what happens in our organization, they check it very thoroughly. So what they have seen is you tend to correct more mistakes, right? When you have been given something, they'll be like, oh, no, this is wrong. And they are very critical of the system. So even these false negatives, like if we miss something or if we added something, both the cases, they are very proactive right now. I don't know how the human behavior will evolve. That's a different study altogether. But because it's newer system and they are very critical and they know that the data needs to be very good. So that's why I think they're more vigilant at this point. Yeah. Yeah. Yeah.
So you mentioned SSD, and I'm sure you tried some simple stuff before, like route.
Yeah.
So that didn't work.
Yeah, so what we tried is basically we took the product or similar products and like if, and then we took similar vulnerabilities that existed and we tried to do few shot or, yeah, tried different retrieval methods like, I think from the cybersecurity team, they suggested an embedding model as well. We tried with that to retrieve. So the retrieval, I would say, went well, but then actual generation, it didn't go well, and yeah.
I just wanted to mention liquidation, which always is the case.
Yeah.
So, but yeah, so, the other question is, so do you have any, let's say, auto validation mechanism or something in place when you like to, when you're training the model, right? Make sure it still performs well on previous data, or when you want to update the model. So how do you verify the model? How do you verify that one whenever you train? Have a procedure for that?
So right now we don't, but we are actually recently trying if some other procedures like some weighted samplings or reinforcement learning, will that work or not? But it's still under, or like, yeah, we're trying to see if it works.
Yeah, one quick question.
Sorry, I actually didn't get your question. Can you repeat?
Sorry. That should using like wise fine tuning.
Right.
Reservation.
Yeah, so we are actually currently we are also training with like human feedback and seeing if that system does better. But still now, like right now, we are actually working with Quen models as well and seeing, but still it's not performing better. So yeah, but maybe with the like, there are many newer papers that has shown that with reinforcement learning you can perform better than SFT. So we're hoping that we'll get there.
Great. So in IAAI, because it focuses on deployed applications, for all the deployed papers and the deployed track, we give awards. Present this award to you. And I'd like to invite our next speaker, Ahmad Ridley, who will talk about the efficacy of multi-agent RL for cyber defense. Let's see, do you have the dongle for the pointer? Yeah.
Okay, good question. I'll try to step first. This would be that, and then here, and then oops, and then you can just yeah, you could go. All right. Few websites. Okay. When you were done, I'll just share the screen. Oh, all right. Okay, thank you. Thank you. All right. Good morning, everyone. My name is Ahmed Ridley. I'm a researcher at the U.S. Department of Defense, specifically NSA's Laboratory for Advanced Cybersecurity Research. And I'm going to talk to you about our submission, which was a collaboration across 5 different countries, the UK, Canada, Australia, New Zealand, and the US, focused on developing a research framework to train multiple reinforcement learning agents to mitigate cyber attacks. And so over the course of about 4 years, we introduced 4 different challenge problems. I'm going to focus a lot on the 4th challenge problem, the most recent one, which was the focus of our paper. I'll step through the cyber scenario and some of the tutorial that talks about the code related to installing the software, what types of observations are seen by the agent, and then essentially how to train the agent. And so what we're training are defending agents, which we call blue agents. There are red agents in the environment that are somewhat scripted, finite state machines. And so I'll talk about what those agents see and what they're able to do, actions for the red agents, actions for the blue agents, and some of the capabilities of the normal users, which we call green agents. But I'll start first with setting up the scenario for the 4th challenge. And so I mentioned this was a collaboration across 5 different nations. It's called the TTCP, the Technical Cooperation Program. And so what we did, there was an interest across all of these nations in understanding autonomous cyber response. So oftentimes when you hear AI applied to cyber security or cyber defense, you think about detecting anomalies, finding other irregularities, finding malware on a system. And all that information, all those alerts potentially would go to a human or group of humans, human operators, teams, and they will figure out, what do I do next? Is there nothing I need to do because it's not a threat? Do I need to isolate a machine? Do I need to patch a system? Do I need to block some processes? Do I need to block a download or attachment or access to a website? What our focus of the research is, once you have all that information, can we train an agent to autonomously respond in the way that a human operator would respond? The motivation here is the lack of enough cyber expertise among human operators to mitigate threats across all types of networks. And so looking at autonomous agents that could respond to threats in a similar fashion, or maybe even better than humans, was a part of the motivation. And again, we're not replacing human operators. I think at this point in the evolution of AI, although it can do some really great things, that there are some tasks that humans are still better at, but they could be augmented by the capabilities of these agents to handle some tasks that are routine, that the humans can trust the agents to respond to. So that's a little bit of the motivation in the background. So part of the challenge details, as I mentioned, we have these agents, and I'm going to make the diagram a little bit bigger. It's a little small detail. So we have 5 subnets, part of a larger network. On the right side of this diagram, you'll see kind of the headquarters facility. There are 3 subnets there. If you see this blue shield here that I'm touching there, that's the agent that's in charge of, responsible for monitoring that network from attacks. And then we have 4 other subnets. In the upper left, we have a restricted zone and operational zone. Those are 2 different subnets with 2 different agents monitoring those networks. We have similar networks at a different facility. Again, those 2 different zones and an agent monitoring each one of those zones. And then we have a contracted network in between that does not have an agent there. And we're not disparaging contracted networks, but we're assuming that the attack will emanate from there, and it's more efficient to try to mitigate the attacks on these other networks. So as a government network, we don't control what the contracted network looks like or how it's defended. So again, the motivation for this example are a contractor network where they're controlling drones that are surveying for a military scenario. So think of drones surveying the boundary of two nations, and they're reporting back, they're sending information back to one of these facilities, either the one on the left or I'm sorry, the top left and bottom left, where there are folks there monitoring the activity of the drones. And so we want to make sure that these drones, the mission of the drones can operate as planned. And we want to make sure that the networks are being defended from cyber attacks. In the previous challenge problem, challenge problem 3, that's also available on the GitHub page, we had agents monitoring the actual drones. So 18 different drones, monitoring those drones and taking actions to prevent those drones from being attacked. So an attacker couldn't take over those drones, block the transmissions of those drones back to the network. Here, in this scenario, we're focused more on the actual networks, enterprise networks here. So one of the interesting parts about the way we're training agents in this scenario, so I mentioned that the red agents can start on the contractor network, and they can laterally move to other parts of the network. Each reinforcement learning agent that's monitoring its particular subnet can operate independently, but there's a way for them to pass a small message, an 8-bit message between agents, identifying whether or not they've blocked access to their network from the agents. And the reason that that becomes important is because the configuration of the network can change over time. And so we built into the scenario an ability to sample for each episode on which you train the agent, a different size of the network. So we can have up to I think 6 different servers and up to 10 different hosts on a subnet. And so as each agent is learning to defend its particular subnet, it sees a variation of its environment during training. Again, this is to help build robustness in training. So last week I mentioned domain randomization. So this is a bit of automatic domain randomization to make the agents robust so that after they've been trained and they're deployed, if they see some variation in what they're trained on, they can adapt, and that the policy that they learn here can still apply with some fidelity. And so the agents are training on a changing network environment. We also, as I mentioned, we have normal users, which we call green agents. And these normal users on the network, they're either, if they're in the operational zone, they're directly
Good. You are
facing
early.
with the drone mission. If there are other users on the network, they have other work or capabilities that they need to accomplish on an enterprise server that's local to them or on a different subnet. And so we have local work for the green agents. We have an access service running where these access different parts of the subnet. And so as the RO agent is mitigating attacks, blocking the red agent from moving from host to host, compromising critical assets on the network, we also wanted to learn to take actions that don't unintentionally or unnecessarily impinge on the work of the green agents. So I should mention, and I'm going to switch over to show you some code in a bit. This is all in a simulation version of the environment. And so again, what we believe is unique about this is there aren't that many publicly available cybersecurity environments to train RO agents in. And this one particularly is multiple agents. So when we started this in 2021, we trained a single RO agent to mitigate a network of 18 hosts.
I already
through 2024, we've extended that
invite,
to multiple agents across multiple subnets and much larger network size. Built into the simulation, there are processes and services running on each host that the red agent, the attacker, can compromise. And one of the defenses that we have
sometimes have this problem.
The blue agent can deploy deceptive services on those hosts to delay and confuse the attacker. So as the attacker is trying to scan which services are running on the host to determine what exploit to run, if they spend enough time trying to exploit decoy services, that's less time they exploit the real services. And that's a win for the blue agent.
Okay.
So I mentioned the network connectivity and the communication policy. I showed you the diagram of the
Yeah, I'll do that.
the network configuration in the beginning. And so there are firewalls or routers between each of those subnets. During training, I mentioned that the size of those subnets can increase or decrease. We randomly sample that. But the other aspect of this problem is that there are three different phases of the mission that are running during training. And so during the pre-planning phase of the mission, the network configuration is as initially configured. But as we move into and the chart is to show the connections between the subnets. So, for example, for the contractor network is connected to the headquarters network. It's connected to everything but the operational zone A.
They call me first, yes, but I want to.
But as the mission begins, and if it's mission A, where the operational zone A subnet is most important, we see that. So you can see that operational zone A, you can see the zeros and ones identifying the connections. We move down to mission A and we look at operational zone A.
Last time
there are some ones that are missing, some connections that are missing. And so as the training environment episode progresses, the configuration of the network is changed.
I cannot do that either.
Indicating that, and this is to help the agent learn that some actions
I've never done that
best suited in the pre-planning phase for one configuration.
These days we all use Zoom.
Is no longer the best action to take when the network configuration changes. And so that signal is sent back to the agent in terms of a reward. And so in our simulation, in this environment, in this scenario, all the rewards are negative. So there are penalties. And so if the agent tries to take an action that's no longer valid for this particular configuration, there's a penalty.
Right.
If it takes an action
that the phone number
there's a penalty there. But if it happens to take an action that prevents the red agent from achieving
because Stella needs to add the number, otherwise it goes to mail voicemail.
And then again, we have a mission B that's active. Again, the configuration of the network changes.
Okay.
So I mentioned the rewards and negative values. I just kind of went through this a little bit. This is for the rewards for the green agents. So as I mentioned, blue agent takes actions that impacts the local work, the work on the local subnetwork of that green agent. There's penalties there. If it blocks the green agent from accessing services on a different subnet, there's a penalty as well. And there's the red agent is able to impact or gain access to hosts on the network on one of the subnetworks. The penalty is as listed here. Right. And so the rewards change as the mission changes as well. So that's another aspect of this challenge problem that's somewhat unique, especially when applied to cyber defense. So that's the scenario, the setup,
that's great.
The motivation for the problem. So I'm going to switch over to on the GitHub page, we have extensive documentation on how to use the tool, how to set up the tool, how to get started. So there's some installation instructions here. But what I'm going to highlight, excuse me, is some of the challenge details.
No, but just a question: why don't
I talked a lot about the setup, the environment,
instead have to
what the network looks like. Some of the green agent activity. But what I'm going to move to here, this is kind of a summary of what I talked about before. I'm going to move to the tutorials. And I want to show you some of the observations that each one of these agents sees. The blue agent that's defending the network, the red agent that's trying to attack the network.
Like let's say for Stella, like somebody's trying to get into her account to breach. We don't.
So here in the observations,
for security purposes, we have to ask for that PIN number.
You can set up. We give you an extensive list of code, or I'm sorry, short code that explains to you how you can see which agents are active. I won't spend much time here on that. But what I really want to highlight are the observations. So for the attacker, for the red agent, if you wanted to understand the types of observations that the red agent can see as it's trying to perform lateral movement and move to the network. some of the Python code here.
Right.
The underlying simulation environment that we're using is called Cyborg. There's a paper on archive that details all the that lists all the details about Cyborg.
Not
This tool was
sure.
created
Probably
by
she
young
wants
researchers
to
in
make
science
sure
technology.
her opinion is considered.
So you can see that there, but we wanted to give you a little bit of code.
If that's
And so the
taken
output of this
care
code,
of,
if you wanted
maybe
to see
it
what
doesn't
observations the red agent sees
but I'm not
as the
sure.
game starts, you can see interfaces of a particular host. So the first key there is the user host 2. So that's the name of that particular host where the attacker has a foothold.
No, that's all.
You can see the interface information. You can see processes that are running, services that are running. You can see a systems info, type of operating system, version of the operating system.
Thank you very
and
much.
whether or not
Okay.
the attacker's command or action was successful or not.
Thank you.
So in the beginning,
Okay.
at the first start, the attacker has not done anything.
Bye-bye.
So you see the last line of the code, the success is unknown. But as the attacker starts to take actions in the environment, that information changes, and you can determine if the red agent can determine if his action was successful or not. One of the actions that the attacker can take is to escalate his privilege from a normal user to a root user. And so, again, part of the observation for the red agent is to see if they've gained that additional level of access. Right. So, and then again, here's code that will let you understand exactly what you can do as a red agent, what actions you can take, what observations that you can see. And again, the red agent is scripted, so it's not learning about the environment, but the blue agent is. And in terms of the blue agent, a lot of those observations that you would see for the red agent, you can see for the blue agent. Here's some code that will list all the different keys for the initial observation of the blue agent. What you would see there, again, interface information, what processes are running on all the hosts that a particular blue agent is designed to designed to monitor or protect on its subnetwork. You can see the system info and the user info. You can also get information about uneventful steps. So in the simulation, it's a turn-by-turn simulation. And so the attacker takes an action, the blue agent will then take an action as well. And so some of the actions that are taken can take one step if they're simple actions. Others can take multiple steps if they're more involved actions. Again, to try to simulate a realistic setting. So as I wrap up, let me go back a little bit to show you the types of actions that the different agents can take. And then I'll kind of wrap up there. Sorry for the scrolling. So I mentioned the different mission phases. I mentioned the rewards, and scroll down. For the green agent, I mentioned that it can access services across the network. It can access services on its local subnet, that's local work. For the blue agent, it can monitor, which is a basic collecting of alerts across all the different hosts that it's responsible for defending. The analyze action is a little more involved, so it can increase the monitoring, can increase the collection, especially if it seems like there's something suspicious happening on a host. The blue agent can run this additional action. You can see that it takes has 2 time steps to complete versus 1 time step. And so that's an additional cost to the blue agent, but the reward could be that it learns with more certainty which agents are compromised. I'm sorry, which hosts are compromised, so that it can take an action such as deploy decoy. It can remove a red agent that has user level privileges. It can try to restore a host or by removing a red agent that has root level access. And once the red agent has root level access, it can impact a server on the network. And once it impacts the server, it can bring down substantially, it can degrade substantially the work that's being done on the network. The blue agent can block traffic and allow traffic on this network, so it can change firewall rules on the network. And in terms of the red agent, it can discover remote systems. It can do that stealthily or it can be more aggressive service discovery. and then they can exploit services and escalate its privilege there. All right, and so as I wrap up there, just wanted to mention that we had a web page that automatically evaluated submissions. We had over 38 unique performers, companies, academic researchers that submitted trained agents to our challenge problem. 118 submissions in total. Some folks submitted twice. And I think I have a leaderboard or yeah, so initially we had a leaderboard here. I think the highest submission was about a negative 158 in terms of reward. Again, we had a lot of only negative penalties, but we had kind of the top 2 or 3 users, performers, submitters are in that range, and then the rest of the folks were below. So we're really happy with the adoption that folks used with this environment, and the fact that they continue to use this to train students and train novice cyber operators how to defend networks from cyber attacks. So I'll stop there.
Thanks for the great talk. Can you please look a little bit to what were the best strategies that you saw that handled this?
Great question.
I'm familiar from pages 1 to 3 that in the demos and hierarchical level like work best. How do these trends that work there adapt to these solutions for page 4 and put it like the same type of best job winner?
Yeah, great question. Could you repeat? You said challenge. You were familiar that with challenge 3 that they were. Oh yeah, ensembles. Yes. 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 So great question. So in the paper that we submitted to IAAI, we had the top 4 performers talk a little bit about their approaches to the problem. So yeah, we did see the hierarchical approach, not as many ensemble methods. One of the things we noticed in the first few challenge problems, they were easy enough where people will use rules. So more of an expert systems type of solution where they could identify the type of attack and then train an agent to handle that particular type of attack. As we made the challenges harder and the attacker varying the way that they can approach it, we saw ensemble approaches, hierarchical approaches still, and some of the RL approaches, deep RL, PPO, multiple PPO trained agents in that sense. And for this challenge problem, I think we made it even harder. And so it was a lot more harder for traditional RL, kind of standalone RL solutions to work alone. So you still see a little bit of the hierarchical rules-based approaches there. But we did see a few more RL-based approaches, PPO. Obviously, it's a multi-agent reinforcement learning system, but still using some of those same techniques. Yeah. Thanks for the question.
Like to say, like after being sucked away from like the critical and some of the things
Yeah, that's a great question. So I didn't have a lot of time to get into that. So one of the other aspects of this research that was really that really made us happy was that another government agency, DARPA, decided to take on this problem at larger scale. And so the folks who submitted submissions to this problem are also working on that research. And they are doing emulated environments as well. So realistic systems, real operating systems, real network protocols across various types of networks. So not just enterprise networks, but critical infrastructure networks, wireless networks, 5G type of networks. And so at some point, they hope to make those capabilities open source. And so you would be able to not only train agents to defend networks, but train agents to attack those networks at a much more realistic scenario. And the final goal of that program is to deploy these agents on real systems, right? So everything is tailored towards that. And so that would be a way to answer your question. You're welcome.
I have one follow-up question.
Sure.
So you talk about this environment that's being used to train, essentially to train blue agents and to test out how to do.
Yes.
It sounds like the red agents are prepared ahead of time.
Yes.
for the challenge.
Yes.
How hard would it be to extend the environment so that the red agents could be sort of adapted in real time as like a red teaming
Right.
to test, like do a live test or experiment?
Right. No, that's a great question. So it's kind of related to his question. That program that I mentioned from DARPA, the folks who submitted to our challenge problem have already created the same challenges.
Oh.
Challenge cage 2 and 4, where they have red agents attacking. So they're learning as well. So they're AI agents as well. And they're even allowing humans to be able to interact with the environment as well. Yeah.
Sorry.
No, so I didn't specifically address it there, but it falls under that. Yep.
Okay, thank you.
All right.
So what we'll do next is sort of roundtable discussions. Sion's going to put up a slide discussing, overviewing the topic here. So I believe it'll be about the pros and cons of open AI tools, not open AI.
Yeah.
And so we want this to be interactive, and I guess we'll split into essentially 2 groups. Those who want to come up with ideas that are pro the openness,
Just assume.
against.
I think it's already in.
We want to maybe
I think
get
it is
some
in the Zoom, at least it should be.
human
should
But
be.
if it's not.
I just need to
experience
first.
where we can get
Yeah,
together.
exactly. I counted, let's try to make 4 tables. So we take these 2 tables and these 2 tables. If there's an overflow, make it 5th one. 2 tables will have the authors. The authors of the second paper, I would say, is on open models, and the author of the first paper is on closed models. And I will, as soon as it works here now, share my question. Yeah. Okay. Perfect. That's the basic question. Open AI models, cybersecurity asset or a liability. If you're in favor.
I think you have the.
So if you're in favor, here is basically what you can discuss. Discuss how open models can enhance security, facilitate collaborative defense, and democratize AI-driven protection. Against this statement is here. I will leave this slide up so you can always read it. It's debate the risk, model misuse, increase attack surfaces. You can read it. And in the end, please nominate 1 speaker for your table. So your table can then summarize what you discussed in a short statement. Okay? So it looks like we're more like 3 tables. But whatever, pick against or in favor, and then let's discuss for around 10 minutes, 10 to 12 minutes.
The models are great. With the agenda, everything be open. One is all that. Where people sit. The green thing better, it could be open. I suspect taking aside of this video tutorial person, but see if all that would go forward and pretty similar.
So
I will say still one.
So yeah. Right, right. They have,
potentially this could influence other related areas, acting or
But you can seal your mouth gets easier, but it's still what's the words and it's unless you probably know the English study short. So I think in the postal setting, I mean, during the voice names, but I think even like sure sort of like timing sounds as well, right? But I think that like you can do point like even with the source at the same time, there's a lot of like that's to get around that, I think. That's something that I didn't yeah, by different. I guess the positive for it to see from the because of property, but maybe the security aspects of it. I almost like I think techniques and approaches should be like open source, but maybe like the models themselves and the data you train them, and not so much. Because again, like it's also very a lot of the data is like so diverse as well. There is no like to my mind there's no one general solution. But I don't know how helpful it is to well this makes sense.
yeah, so that
No, and it's very It's qualified. But it's, that's great. That is sort of a sort of initiative.
So, there's no science that they found.
Then I'm like, it's very hard. But having power things together. Even have a little bit of working. Yes.
So now that it's not like bad, all the time. And then it's all.
So like there's several. The UAI. Thank you. Yeah.
Ready? Sure. Ready? Let me start here.
Check there. Table in favor.
Okay. Just give some attention. Okay, so I'm gonna mention some of the points that came from our discussion. Disabled in favor of open source models. Please chime in if I'm misinterpreting any of the comments. Now look at my notes here. One of the first topics that came up was the open source enabling collaboration, and here's an example of that today as well. And Ted mentioned some of it. I'm coming from the finance industry, work with direct investments, but we have a lot of open source libraries that actually foster such collaboration. So that's something that came up. The security aspect, we talked about prompt injection. There might be some guardrails that's out there in closed models, but you can still bypass them. And wouldn't it be better if there's transparency and multiple people with different backgrounds and various domains working on these open source models to address these gaps? So that would not be possible if these models were behind those closed. There was maybe a little bit of reservation in terms of what we exactly mean by open. So maybe the algorithms, the model, but case by case on the data aspect of it, given some different lots of diverse data in there. So maybe there's it's not a maybe there's a case by case reasoning there. One comment came out about the enterprise AI aspect of it. In favor, one comment was open source models reducing the cost of access, and if that is the case, that might lead to wider adoption, and not just by large companies that can afford it, but for mainstream use, and possibility of keeping some things open, but at the same time offering managed services on top, so that you have a little bit of a hybrid of best of both worlds. A good example of that is Scikit-Learn is open source. Probable, it's a company built on top that provides the managed services. It's actually how to make that connection, and that's how we've seen the difficulty of taking these algorithms and integration. So there's still value that enterprise can get, even though models are open source. And maybe a last comment was on the environmental aspects of it. So if you're more cognizant about the impact and share that with the community and be open about it, that could generate wider acknowledgement of some social impact. So I didn't miss any points. Any others about the chime in? Okay, so these were our points for taking favor. Then let's see what the other table discussed. Who will speak for you?
Thank you to the table there. On our end, we did a mini poll to start on where people sit on like how in favor or how against. There's actually a surprising number of people on the 9-10 range in favor versus 1 being against. So naturally, I declared myself one and tried to argue with everyone to see where we wound up. And I think I got everyone to a 7 or thereabouts. We'll see. Great points on your end. Many of them mirrored over here. We don't need to say them again. I think we talked a bit more about privacy and the implications for openness with respect to maximally open models where the data and the training script and the model configuration are all available. And just the inherent challenges of addressing those privacy issues versus trying to open source things, and how very often there's a practical trade-off as doing things in the health sphere. And is there anything else that the table would be bringing up?
Make the bad part of your sponge farm. That's fun.
Yeah, that was my argument, but I was arguing a little bit in bad faith, so I was. Okay, bad faith, but it is also true. And that is the challenge, and where I think I would probably speak for most of us here when saying this is not a either or proposition. That there's that messy middle that we need to operate within, and that's the fun part about applications work is we get to figure out how to do that. Come visit poster.
So thanks. We halved in participants for the discussion, but at least you stayed here and we discussed it. I liked it. And now will be the poster session. So the people that presented will be at the posters, and also the others that will present throughout the day will be at the posters. We have our own session, a section in the back right. It's like marked for IAAI, so you can find them easily. And there will also be lunch provided. So cool. See you after lunch.
Now section.
Yes.
Number of
Is mine. Yeah, because I gave it to him was on this. So the only energy outlet that I found is underneath.
Oh, yeah, it's like everybody. Oh, I hope everybody's. This one started.